Brilliant. Okay, so we'd just like to introduce Daniel Woodworth of Dayworth Consulting. If you'd like to introduce yourself, Daniel, and then feel free to go. We're really interested in understanding about smart DMAs.
Okay, yeah, well, thank you very much, Michael, and thank you very much, everybody, for inviting me to speak here this afternoon. My name is Daniel Woodworth. I'm director and co-founder of Dayworth Consulting. We're a new consultancy to the water sector, and we specialise in smart water solutions. So I'm here today to talk to you about how one water utility made their DMA smart. And that one water utility is SES Water. And my link to SES Water is that I spent the best part of 12 fantastic years working for SES Water between 2011 and 2013, where I held a number of roles, starting from sort of operational leakage through to network strategy manager, and then just before I left to form Dayworth as a head of asset strategy. And during that time, I got to work on some fantastic projects, and none more so than the one I'm going to speak to you about today. When at the start of the current AMP, I was given the remit of designing and implementing a smart network for the business. So fast forwarding to 2022, we won as SES. We won an award, Smart Water Initiative for the Year at Utility Week Award, an immensely proud moment in my career, and immensely proud for SES to do so. So big thank you to SES for allowing me to speak effectively on their behalf this afternoon, and I will be sharing with you sort of some of my experiences as an SES employee as we rolled out this solution, but also now as a consultant in reflective mode, thinking about how what we learned from that process, and to hopefully give some tips about how others can implement smart DMAs themselves. Okay, just try and move the slides on. Okay, so for those of you who've seen me present in the past, I normally like to get some sort of audience participation or thinking going as I'm going through. This being a webinar, I can't really do polls and I can't really do hands up, which is another tactic I like to use. But so what I'm going to do is I'm going to pose a few questions at the start, and what I'd like you to do is have a think about these as I'm going through the presentation. So three simple questions. What does smart mean for you? What's the value in it? What value are you trying to gain? And then what's the success criteria? How do you know if it's worked? And I'm asking these questions for a reason, and it's because these are the questions as a head of in a water company you get asked to provide to your executive in a business case. And these were the exact questions that came to me at the start of AMP7. But I think the great thing about working for SES Water was I was given the time and the space to answer these questions, in some cases as we went along. If you try and answer all these questions up front, you will end up constraining yourself. So I think it's really important to think about these things, but don't be bound to them, because you'll learn as you go through the project. And hopefully I'll demonstrate that in some of the things I show you this afternoon. Okay, so just to set some context, the obligatory SES Water slide and where they're based and how they're set up. So the second smallest water-only company in the UK, population of 300,000, a mains length of 3,500 kilometres. In terms of the network, just over 300 DMAs, very well established DMAs, and quite a high degree of pressure management as well, both in terms of coverage and in the sort of amount of pressure that's managed through that. Average zonal night pressure of about 40 meters head. So why was SES good for introducing a smart network? And I've just listed a few things. Well, the main one was there were already very well established and consistent DMAs that had been in place since the 1990s. And what that gives you is an excellent history and an excellent benchmark of your data, so you can understand, the benefit of what you're bringing in on top of what you already had. The area itself is very geographically confined, situated just south of London on the Kent-Surrey borders. And so that meant we didn't have huge issues with needing different types of communication networks in different regions, quite a confined region. And one of those things was we soon realized we had very good NBIoT coverage, and you'll see why that was important as we went through the project. And the people, really good people that know this network like the back of their hand. And that's something that you can't underestimate, because however good the systems are that you bring in, you need the people to operate those systems and understand what it's telling them. So when we set out, as you do when you start any project, you think about what your principles are and what you're trying to achieve. And I had one very clear overarching objective, and that was to reduce leakage. So SES Water were funded in PR19 for a smart network in order to as one of the levers that were being pulled to reduce leakage by 15%. So that's all well and good. That's an overarching aim, but what did we break that down to? So there were a number of things. Firstly, we said we want to live this concept of a golden hour. So we want to be on top of things within the first hour. We want to know about them and we want to have actioned them. So when customers ask, what's going on? Why haven't I got any water? Why can I see water running down my street? We would know. Secondly, we set out to create dynamic real-time alerts with high confidence levels. Had to be dynamic, had to be real-time. That was one of our key things that we said it needed to be. We wanted to involve our staff, and I've already mentioned this, but we wanted to put knowledge at their fingertips. There's nothing more frustrating being out on the ground if you don't have information, or if the customer, even worse, if the customer has more information than you do. So that was one of the key things, is to put knowledge in their fingertips. Everything had to be data backed. We were very clear from the outset that we didn't want to be making decisions unless the data had told us to. And overall, we wanted to reduce leak runtime. And by that, I mean impact and I mean volume. Because we knew if we can do that, then we would be meeting our objective of reducing leakage. So those are the key principles. And now I'm going to talk kind of more generally about building the smart network. So again, for those of you who've seen me present on this, we've shown a stacked model. And the idea was that you build up your smart network in layers. For this presentation, I've just refreshed that a little bit, because I think we did learn that those layers don't necessarily all go down one on top of the other. And actually, there was through the early trials that we did in 2019, we realized there was some basics, or a base level, that had to be got right first. So the first of those base levels is well-established and stable DMAs. A point I've already made, but crucial, absolutely crucial to setting a benchmark and a baseline to assess what the smart network has actually achieved. And secondly is reliable and accurate sensors. Now, in some of our early trials, we soon realized that actually where we thought we had good data, we didn't. We had data that was fit for nightline reporting, next day or overnight reporting of leakage, definitely not fit for near real-time reporting. So we had to address this. And before we did anything else, we swapped out all of our sensors for new NBIoT sensors in order to be able to, quite frankly, to be able to carry on with the project. So once we've got the basics right and the baseline set, we can then move on to building the smart part. And the first part of that is the communications network. So the comms layer is the bit that gets the data back to your premises, to your systems, in order for you to make do the analysis and make decisions on it. But it's not one size fits all. So at SES, we went for the NBIoT solution. As I said already, we had good coverage, and early tests showed us that, and that worked for us. But reflecting now, there are a whole host of decisions that go through your mind as to what's available to me. Is this going to fit the whole of my network? Am I trying to do other things? Smart metering, for example. Do I need a different type of solution that can absorb different data types alongside my smart network data that's coming in? So the next layer, which is enhanced data processing. So this is the smart bit, if you like. This is the enhanced the AI or machine learning or whatever it is you're using to take your data and turn it into useful insights. And at SES, we partnered for this. We decided to buy this in effectively. And we went for a cloud solution provided by Royal Haskonian DHV. At the time, it was called AquaSuite, and it's now called Twin. But again, the one learning I would give here is to say, there's different routes you can take. You could try and develop something yourself in-house, and there are larger companies than SES Water who would probably have that capability. But I think what we learn is don't try and do something better than the experts. The next layer is enhanced and real-time visualization. And this one's important because, again, you can have a really good system, really good software, really good algorithms, but unless it's presenting it in a way that your staff can use it, it will be more or less useless. And so we were looking for a user interface as part of this project that our staff could engage with, interact with on a day-to-day basis as part of their business as usual activities. And there was a lot of work that went into developing this as we went through the project. And finally, this never used to be in my stack, in my layers, but reflecting on it now, I think it's so important that at the offset of developing a smart network, that you think about how you're going to maintain and operate it. It's quite easy to forget about that and just do it, and then worry about that when it's been rolled out. But it's crucial. How are you going to maintain those sensors? Have you got the teams in place to maintain those sensors? How are you going to get alerted to the fact that the sensors might be having difficulties? And defining clear roles and responsibilities around this, I think, is a really important step in building a smart network. So those are the building blocks. I'm now going to take you through quite quickly and not in too much detail how iDMA works. And you'll see it follows that theme of building up through those layers. So the first one here is sensors and comms, which I've combined on this slide. And the key thing here, as I've already said, was the move to NB-IoT. So that was the communication method of choice. We then had the sensors that were able to leverage and use that technology. And as I've said, it was a major upgrade for us to move to a greater granularity of data and a huge increase in the reliability of that data as well. So the little table you're seeing there, that just compares the iDMA stock of sensors to the post iDMA stock of sensors. And you can see that we replaced every single one with 15-minute data, giving us 1 minute averages in flow and pressure, plus some additional channels that came as a bit of a bonus as part of that upgrade. Crucial as well as the expected battery life didn't change, and NB-IoT was the key enabler for that. These small packages of data that you can send via NB-IoT that mean that you're not killing the batteries of your smart sensors. Obviously thinking about whole life cost and maintenance as well on those sensors. But this was a crucial step in getting that near real-time data that we knew that the software would need. The other thing to point out on this one is the dedicated chambers. So you can see there a picture of one of our sensors, one of our loggers in its own chamber. We invested a lot in going around and ensuring every single sensor had its own chamber and was looked after. Where there was marginal signal, we deployed additional aerials as well. But I can't stress enough how important that was to get that maximum reliability of data. If you look after the sensors, they'll look after you. So going up a layer to the data processing. So as I've said, we partnered with Royal Haskonian DHV with their twin solution. The product's called Burst Alert, and this is how it works. So you're seeing there the trend that is produced. It takes historic data and produces a forward demand prediction on that data. It does this for flow and it does this for pressure. And it looks 48 hours into the future at all times. We like the solution because it was calendar based. So it learns from previous Wednesdays or previous certain holiday days. It knows when it's school holidays. It knows when it's Christmas. So it will build up over time a really good knowledge of what data consumption should be. Obviously, it's very crucial that you have that historic data, back to my point about having that sort of longevity of stable DMAs as well. And then it produces a limit line, and the limit line is what it then references against as to whether the area is in alarm or not. And the other clever thing about the software is that it has different filters. So these limit lines can change depending on the filter you're looking at. The idea here is that it gives you the ability to be alerted quickly to large events, large leaks, if you like, on certain filters, whereas on others it will say, actually, no, I need more confidence. I need longer to decide, but I will still alert on a smaller leak. And that's just stops you getting too many false alarms. Of course, this needed a lot of training, a lot of fine tuning in many cases. But one thing I was really impressed with is how quickly it got to a stage where it was producing reasonable predictions. And it was then just fine tuning that had to be done to make sure that the alarm levels and the sort of alerts that you're getting were the ones you wanted. Then to visualization. So here are just two screenshots of effectively what you'd see if you were sitting in SES Water's control room. An awful lot of work went into the development of this, and we were really pleased to be able to work with Royal Haskonian DHV to co-develop a lot of the UI that you see there. And it has evolved over time as well with user feedback. Again, you think buying a product off the shelf, it's never going to be perfect for your organization because everybody has their own wants and needs. And that's why it was important to partner with somebody like Royal Haskonian DHV who were willing to allow us to tweak things and change things to suit. So the controller would see that, and we built a whole suite of processes around this to help them use the software. Again, there's using the software and the user training that comes with it, but there's then using it in the context of SES Water. And so we built a whole suite of processes, responsibility matrix, etc., around the visualization. Which brings me to the next point, and that's the people layer, which I deliberately left off of the layer stack, but it's so key. Bringing in this software, getting it all up and running as a project team, the handoff and the handover to the teams that are actually going to deliver this can't be rushed. And we did take a number of months in order to properly train our teams. We used it as a wider training opportunity as well. So at the time, rolled out some hydraulics training as well as part of it to network inspectors and to the control room operators. And this helped them get a real understanding of how the network worked and why it was we were bringing in this solution in order to enhance that and make it better. So I'm now going to give you some case studies. And these are examples to show you how the software and how the solution is working within SES Water. So, example one. Unashamedly, and I have got lots of stick in this for this in the past, but this is an example I've used many times in presentations. But I'm not going to deviate. I'm going to use it again because it really is a very, very good one, and it showcases what the software is all about. The fact that it happened on the first night is just a very nice sweetener as well, because it really was the wow moment for us, and the kind of high five moment the next day. So what you're seeing there is well, the graph is showing the trend that we just saw on the sort of idealized version, and you're seeing there a large deviation from the trend that's breached the limit line. And then the color blocks overlaid there are the alarms. So red alarms, or dark orange, as it's displayed here, are critical alarms, and we have the processes that we built around that state that a critical alarm needs to be acted on immediately. So if you follow along the top there, you can see that at just midnight, a leak broke out at it was 10 litres a second. The software will tell you that. The software then, as I mentioned about the filters, then takes a little bit of time just to make sure. So it will measure a few more time steps. Now this was in the early days, so it did take an hour or so before it was confident enough to alarm. But at 2:45, it sent the alarm, the critical alarm. So by 3 a.m., sorry, the control room operator had correctly interrogated that alarm in the software, and they had followed the procedure that they'd been given just a few weeks before in the training, probably slightly panicking as it was the first time, and they dispatched a network inspector out to site. The inspector attended site and by 6:30 a.m. had pinpointed through correlation, or well, in that case, I think it was visible, but they pinpointed the source of the leak and the location. A repair team was called immediately, went to it as their first job, and by 12:45 p.m. The repair had been complete. So that leak had run for 12 hours. We then did some analysis, and we said, well, let's pretend that we didn't have iDMA. Let's pretend that we'd have done it the old way. And we calculated that we could have saved 2.9 megalitres of water there than if we just done it the old way. So a really good example, and got everybody very excited about the potential that this could bring. So just to show that wasn't a fluke, just in producing this presentation for today, I called up the SES team a few weeks ago, and I said, can I have a really up-to-date example, please, of how iDMA is still doing exactly what it did on that first night? And lo and behold, we got an excellent example provided for me. This one was on the 4th of September. And as you can see, again, following along the top, at 1:15 a.m., there was a 15 litre per second leak, or anomaly, I should say, was identified in this particular DMA. The alarm was raised by 3 a.m. in a critical form, and then a dispatch was made by 3:30. In this case, by 5 a.m., we had pinpointed or located the leak. And then this one took a bit longer to repair. I didn't ask the specifics, but I imagine there were some engineering difficulties in actually getting to the location and getting it dug out. But in total, 21 hours on this particular leak. Crucially, though, it didn't span another night, so it only affected the leakage reporting for one night, which is obviously very important as well. What's changed and what's new about this one is we also had an enhancement of the software in use in this particular DMA, which is the burst alert software. The burst locate software, and that helps to pinpoint leakage using micro pressure variations. So the map you're seeing there, you can see the outline of the DMA. You can see the blue sensors. Those are additional pressure sensors that are strategically placed around the DMA. They are constantly monitoring for monitoring pressure and then reporting on any deviation in that pressure. So when an alarm is raised, the software will launch and it will start trying to solve the problem. And what it's doing there is you can see the dots. So black dots are where it thinks the leak most likely is. Yellow dots are red and then yellow. And then where there's no dots, it doesn't think the leak, or there's a not very high likelihood the leak being there. So you can see, whilst it didn't get it spot on, it's definitely it's broken that area down and put you into an area to go and look for that leak. And that would explain why it was found so quickly. And then the third example I'm going to give is a different type of example. This time not a leak. This is a data issue. And one of the key kind of successes that we probably hadn't really considered. It was all about leakage. But the benefit here is that we had a very early alert to a sensor that was drifting. And I think it was a pulse unit issue here. So it's a dual fed DMA. There was a fault identified on the NOR24 sensor, which is an outflow from the main area. So you can see that data was starting to drift. The balance therefore started going strange. And actually that area was then would have had to have been taken out of leakage reporting, affecting the regulatory availability figure. So AquaSuite, doesn't discriminate. If it sees any deviation, it will alert you. The suite of processes that the controllers have to identify what is a leak versus what is a data issue picked up that this was in fact a data issue and not a leak. And sent a technician out to resolve it same day, and we got that area back working again. Obviously, good for reporting, but also good if in case there are any leakage outbreak in that area moving forward. So I'm now going to move on to talk about how the success was measured. And this was or has been done in a number of phases. We identified that we would need a very long testing phase. There are a number of reasons for this. I mean, partly when we first introduced this, it was COVID times, and so a lot of the consumption patterns were more unpredictable than they would have normally been. So we set out and said, okay, we are going to need an extended period to really test how this works. But secondly, we also knew that it had to go through a variety of different situations, seasons, seeing events and things like that for us to really test whether it was hitting all the marks we wanted it to hit. So I'd say it was probably a full 18 months after go live before we said actually we fully tested it now through every type of eventuality. So as a whole, this is the performance that we found in the first 6 months after go live. And the way we came up with this is we tracked every event that we had, and we compared it to a set of predefined assumptions around what would have happened before we introduced iDMA. These were predefined, so it removed the kind of chance of anybody trying to sort of rig the result. And overall, we saw that there was a 40% reduction in runtime on the larger bursts and leaks on the network. So from 3.9 days on average down to 2.3 days afterwards. So really good performance, and obviously we were very, very excited to see this. And it just so happened that it corresponded. Well, it didn't just so happen. It wasn't a coincidence that it corresponded with a reduction in leakage over the same period as well. Being honest, since then we've seen some fluctuations in that performance. It hasn't always been at 40%. And it has reduced. It has gone a bit higher at times. But consistently, it has come back to that sort of number. So we know that is the potential if we're running all cylinders on this, the potential benefit that you get on reduced runtime. So, as I said, we had to take it through its paces. We had to take it through a number of events, a number of situations. The first one of those was presented in the summer of 2022, when, if you remember, it was a particularly hot and dry summer in the UK. And it really gave us a first chance to see, could the system alert properly? Could it pick up the events that were happening? And would we be swamped? Would we be inundated with alarms that we just couldn't deal with? So I won't dwell on this too much, but no doubt people remember that summer there was a very prolonged dry period. As a result, soil moisture deficit went as high as it's been in recent memory, particularly in our region. And that caused a lot of ground shrinkage and caused a lot of larger burst mains to break out. So it's perhaps not unexpected that we saw an increase in alarms. So just comparing the previous 50-day period and then the summer outbreak period, there was overall 40% increase in alarms, and that was very manageable. And it was very helpful actually, because the feedback we got from the control room and the inspectors responding to these alarms is that it was just great to be able to triage these and compare one against another, and which one was most important to go to, because sometimes you'd have 3 or 4 of these in a single day, and these are large burst mains that you need to prioritize the response to and the repair. And then we moved into a second event, and this was the big one. This was winter 22-23, which again, for those of you who remember, was a particularly testing winter for leakage in the UK. It really tested iDMA to the max, along with the control room and the poor people that operate in there. Were you swamped with alarms? Yes. There were a lot of alarms. The graphic you can see on the right-hand side there is a sort of before and after. A nice calm network with a few alerts, very manageable. And then in the bottom, at its peak during the winter thaw period, lots and lots of alarms. So did we manage to follow up on every single one in the time we would have liked? No. Did we manage to get network inspectors out to every single one in the time we would have liked? No. But the limitation wasn't the software. The limitation was the resources available. Worth noting that AquaSuite didn't, with post-analysis, didn't miss a single noteworthy alarm during that period. We did, because we didn't have enough people to look at them, but the system didn't. So we learned a lot about what we could have done and what we should have done process-wise during that period, thinking about perhaps doubling up resources in certain key areas. And one of the key things that came out of this is actually, as a situational awareness tool, more so than a leakage reduction tool, this is where it really came into its own. We were able to prioritize during that period, making sure that we got to the leaks and the bursts that were causing the most damage to our network and to our customers. And as a result, SES Water didn't have a single supply interruption during that period that was related to the weather, whereas companies in the immediate vicinity to SES Water did. They had huge issues that winter period. And we think a huge part of that success was due to the way that we stuck with it despite lots of alarms, and we were able to prioritize which ones to go to and start working through systematically. So officially tested at the end of that, and actually, although it was a very challenging year, it was very important that we went through those periods in order to understand what the software was capable of and how we needed to adapt to using that software in certain circumstances. So we enter the business as usual phase, and this is the phase that obviously SES are still in now. And it's how do you measure the ongoing success of something like iDMA? So I caught up with SES Water the other day and asked them, how's it going? How are you tracking it now? And I was really pleased to see that they've been working with Royal Haskonian DHV to develop dashboards and ways of tracking success. What was really exciting though for me is to see just how embedded it's become. I was working in SES Water's headquarters yesterday, and a chance meeting with one of the senior controllers, and I said, how's it going? Is it still working for you? And he was, he said it's absolutely fantastic. It's fundamentally changed the way we work, and yeah, how we manage incidents and events on the network. So what are they doing? Well, they've got this tracking system in operation. And so what that's doing is it's telling you things like sensor performance. It's highlighting where, you might need some maintenance. What's your percentage of coverage and things like that. It enables them to complete post analytics on events. So you can see some of the things highlighted there. There was a fire brigade usage in an area that caused a number of alarms. There was an operational, some work done at one of the treatment works. And then you've got a bank holiday weekend in there that was also identified. And all of these is really important because it helps the team to try and help the software to react differently to those events in the future. For example, around bank holidays, there are some system settings that you can change in order to make the system a little bit less sensitive, so it won't alarm on so often for things that you don't really want to know about. And this can very much be used as a training tool as well for system users. So I asked them what else they've been doing, and again was really pleased to hear that they're continuing on with the leak location project. So I've just got a couple of examples here, screenshots. They've got Royal Haskonian DHV are doing this analysis for them. And again, it's trying to really get and fine tune the ability to use the micro pressure variation in an area, the multiple sensors in order to hone in on leak locations. And this is being done in a simulated way. So there have been some test leaks, some hydrant flushes and things, but also done as a post analysis on actual leaks as well on the network. And they're getting some really good results. And you can just see a couple of examples there. This particular one's a bit harder to see, but down in the bottom left of your screen, you can see where the leak was and where this software was telling you the leak was. In best case on some of these trials, they're getting down to sort of 2 or 3 streets. I think we have had one that's been on the same street. And worst case is it sort of quarters your DMA, which still has value. So yeah, early days, but ongoing testing and very much part of SES Water's plans to continue to enhance this element of iDMA. There's further potential here as well in terms of bringing different sensor types in, whether that be acoustics, temperature, even some water quality sensors as well, around chlorine residual and things like that, which could all be used to layer up and improve the predictions. So as I sort of draw to a close now on the presentation and get ready to open up for questions, I thought I'd return to my something to think about. And hopefully you've all been able to sort of ponder those questions as we went through. So I'm going to give you some of my thoughts on each of these. But, remember, I've got the benefit of hindsight, having been through this program and been heavily involved with it, now stepping back and reflecting on it as well. So here's some of the things that I think. So what does smart mean? Well, it's got to make your job, the day job easier for the teams. If it doesn't do that, it's not very smart. Needs to be data-led. I think that's actually a basic of any sort of smart system. Has to use data. Evidence-based, yeah, that goes hand in hand with the data. Works for and alongside the people. So one of the concerns that was raised as we started rolling this out, that we were very quickly able to quash actually, was I don't need another piece of software. I don't need a system to tell me. I know how to do my job. But if you get a solution that actually helps make their lives easier, they very soon come around to the idea that actually they can work symbiotically with this. And you know what? It doesn't have to be rocket science. You know, it's great to have clever things and clever algorithms, and but actually it just needs to do the basics very well and quicker than a human can do it. In terms of the value, this is an interesting one. Obviously, there's some obvious ones here, you know, ODI upside, avoidance of ODI downside. These are key things that the exec will look out for, obviously, in terms of regulatory performance. Favorable unit cost for leakage reduction is another one that we found. That's another way of measuring value. But what I'd say is not to be constrained by what you might see as immediate benefits. There are lots of side benefits. The supply interruptions one was a real caught us a bit unawares, and was another real good one to add to the list. And my other take home from this is don't try and fit it all into 1 year. Certainly not in 1 AMP. You're not going to get your return on investment immediately. If you do, great. But actually, you should see this as a multi-AMP investment for the future, and something that you want to continuously build on as well. And finally, successes. How do you know it's worked? You know it's worked if it is just the norm, and the conversations I've had over the last couple of weeks have shown me that. This is fully embedded within SES now, and the users just couldn't see a life without it. They rely on it. So that has to be the biggest success you can have in a project like this. Obviously, if you're meeting your performance commitments, and I also think if people are talking and still excited about continuously improving it and adding to it, then it's definitely been a success. So, you know, as I draw to a close and reflect, what have I learned most from this project? And it all boils down to one thing, really: work with your people. You know, yes, it's important to get the technology right. Yes, it's important to fine tune those systems and get all the technical aspects correct, but work with your people as well and listen to them. What do they want? What do they want from the solution, and how can it help them enrich their roles and make them do their jobs more easily? So internal stakeholder is actually the most important stakeholder to manage in this whole process. Yeah, so that's the end of the presentation. Happy to answer questions now. If anybody wants more information, there's my email details. Also, Leah Mahern, who is Head of Asset Strategy at SES Water, has said that he can be available to take questions as well. SES love sharing this. They will happily jump on a call or even have you down at head office to show you how it all works. But yeah, thank you for listening.
Thank you very much, Daniel. That's absolutely brilliant. Thank you for that presentation. There's some really quotable notables that I really liked what you put on there. You put, if you look after the sensors, they'll look after you. It's fundamentally changed the way SES has worked. So I think a really, really good story there. And I know SES, and they will work with people. They will share what they've done, that they love to share. Okay, we've got a question here from Justin. Okay, first of all, comment. Good overview, Daniel. Then the question, is there scope, plans, capabilities to incorporate smart meter data in the tool to exponentially increase data points? So I assume he's talking about smart revenue meters. What's the plan going forward? Do you know?
Yeah, a really good question. Yes, the short answer is yes. SES Water have requested funding in the next AMP for a full smart meter rollout, and the plan is to do that over I believe 7 years. So to AMP 8 into AMP 9, and as I mentioned, when we were building the smart network, it was always in the back of our mind that we needed to build a solution that could at a later date incorporate other smart sensors. Just to give you one example of some of the things we were thinking of doing, and I'm sure this is still the case, is having this idea of a property as a sensor. So if you've got smart meter data that's able to give you information about usage within a property, if you supercharge that and actually add an extra couple of measurements onto that, so pressure, for example, you can then use that as another eyes and ears on the network or a sensor in order to tell you whether Mr. Smith, 1 Acacia Drive, has water, and therefore that can help you hone in on where the problem might be occurring.
Okay, brilliant. Thank you. Daniel, feel free to unshare your screen if you want to, so we can see you as you answer these questions. Okay, next one from Gerald. Great, but pressure transient for leak location takes time to steady down. Just kind of your thoughts on that. Is pressure transient a good way to find leaks?
Yeah, I mean it's not so much pressure transient that we're monitoring. It's pressure, micro pressure variations. So it works best, yes, in stable networks. So if you have got a really what's the word, unstable or lots of transients in a network, then it's less likely that the algorithm will converge on an answer. But it's that you're actually looking for very, very small changes in pressure over a minute average, and where the biggest drop has been. So you're comparing between sensors where the biggest drop has been.
Okay, and that takes you to the street or to the area in the DMA that's likely to have the leak or the demand that's unexpected. Just a quick question on transients, because you said the logger has got a transient monitor on there. So is that recording, or is that taking 100 recordings, 200 recordings per second? How's that transient working, or that transient monitor working?
Yeah, so most of the time it sits there just taking, I think it's 100 a second. And yeah, just sits there, but it can be woken up to do full transient analysis if you need it to. But in the normal iDMA software, it's not using that functionality. As I say, it's just looking for these micro pressure variations. So yeah, you could use it as a transient survey tool if you wished. The loggers have that capability, but that's not how it's used on a day-to-day basis within SES.
Okay, thank you. Tony Lopez asked the question. Well, first of all, again, he says, thank you, interesting. Would rolling out a consumer engagement app add additional value to alert consumers to leaks and assist in managing network integrity and addressing leaks?
Another really good question, and yes, it's another thought we had. So there are products on the market which I'm sure lots of water utilities use. I think SES used DigDat, which is a way to alert your customers to events on your network. The vision we had, and again, I'm sure this is still on SES Water's radar, is actually you get all of these systems working together. So you might have a system that does that interface with the customers that can instantly, through API, ping an alert up to the smart network system and vice versa. So the presence of an alarm coming in can then send an API back to that system to tell the customer. Didn't quite get to that stage when I was there, but I know that's on SES Water sort of roadmap for things that they want to look at in the next AMP.
Okay, brilliant. Alan asked this question. This is clearly a great tool to react to new leaks and reduce the running time before fix, avoiding the losses to go higher. Can we somehow use this huge amount of data also to find leaks that have already existed before they embedded into the baseline as expected consumption?
Yeah, again, grappled with this one. I'd love to say yes, and I'm not saying it can't. We didn't yet find a way to be able to use it in that mode. The nature of it is, any sort of machine learning like that is it learns from the past, so it will, in a way, it has to have that baseline. So and also it will sort of build, it builds in errors as it goes in a way. I'd love to be able to answer that question in the future, and I think that is something that companies like Royal Haskell and DHV and anybody who's developing this kind of solution should be looking at. Is whether it's almost like a reverse engineer of the software to look for things that could have been there in the past. But there are other things on the market, obviously, that do that. And I know Paradigm, for example, is one example of software that does that sort of thing.
Yeah, and it'll be very interesting if you get 100% smart metered DMA, then you can see what the consumption is or what the usage beyond the revenue meters are. Compare that to what you expect network leakage to be. Brilliant question, Alan, on there. A question from me. So you talked about it needs to have stable DMAs. Does that mean industrial DMAs won't really work for a smart DMA, or not in this version?
No, they do. They do work. You're more likely to get false alarms in those sort of DMAs because you know, the erratic nature of some of that usage. But actually, I think what we found is you'll be surprised. Even your highly commercial areas do have a very distinct pattern to them. And so it definitely does work. It just takes a little bit longer for the algorithm to learn that area. And occasionally when something changes, you'll get a false alarm and may need to tweak some settings and change some things in the software. But as it currently stands, this is operational across the whole of SES network, including some key industrial areas such as the area around Gatwick Airport. So yeah, it works everywhere.
Okay, and then you gave a couple of examples there of during the night, a burst goes off at midnight or just after midnight. Within 2 or 3 hours, it's alerting the control room. Is it able to do that because it's getting data every minute? So whereas if we had 15-minute data, we're relying on 6, 7, 8, 9 data points, and we're like, well, is that correct? But because it's getting data every minute, is that impacting the confidence you've got or the confidence of the system to send an alarm through to the control room and the control room then to send someone out?
Yeah, exactly that, Michael. Yeah, it's the 1 minute data is key. You know, we worked through this. There's obviously lags between that 1 minute data coming off the sensor getting in to the software. The software then has to process it. But what we got it done in within about 15 minutes, it's collated those 1 minute that 1 minute data. And has done its checks against whether there's a deviation that's against the prediction. But it is crucial that, you know, we tried it with 15-minute average data, it didn't work. We tried it with 5-minute average data, it didn't work. Having that 1 minute data in near real time was critical to the success of the project.
Oh wow! So it really needs granular data. So not even 5 minutes work. It has to be down to that kind of that 1 minute level. Okay, that's really fascinating.
Yeah.
On there, that it needs to be that granular to get that confidence and to get that success rate. Okay, another question from Tony. Were system components, pumps, valves, etc., retrospectively reviewed after leaks for their possible effects on adding stresses to the piping system and maybe contributing to the bursts?
Yeah, I mean, I think that is actually just a standard practice for SES Water. You know, if every major event will have a root cause analysis carried out on it, and that we had that in place before this. Obviously, what this technology gives you is more data and information that can help inform that root cause analysis to identify what might be causing it. An example actually of where this really worked quite well. We had a major burst on the trunk main system feeding Gatwick Airport one summer. I think it might have been during the summer example that I gave you, and we were able to use the data and the information and the alerts we were getting from multiple DMAs to actually pinpoint the source of that transient event. And we tracked it down to a large user in the Gatwick Industrial Estate area, because you could see that the impact was greater nearer to the source than it was further away.
Okay, brilliant. Thank you. That's a really good example. And we've got a question now from Andrew McKenzie. He says, we speak about smart DMAs, but is there a version for the upstream network, or will this evolve over time? So are we going to get smart upstream networks, smart trunk mains, smart transmission mains? Where do you think this is going to lead us to, Daniel?
Yeah, I mean, my answer is why not? Yes, I think fundamentally this technology would work. It's about, are those patterns are the same sort of nice diurnal patterns you get within DMAs? Are they repeatable further back? If they are, then this would work just as well on an upstream network as it would on a DMA network. Um, Again, some of the areas that SES are looking at now in terms of joining all of this up is they're looking at sensors on treatment works. That's partly sort of for asset health type measures and vibration sensors and things like that. But I think in the future we should all be aiming for this sort of fully connected smart network, which is your treatment works, your transmission mains, and your DMA, and your customers as well through the smart metering, and everything talking to everything else, and presenting it all in one visualization.
Okay, we've got a couple more questions then. So, Gerald Murphy, have you used the Construct Smart Consumer Meter, which integrated hydrophone and correlation in the cloud? Normally, NBIoT allows up to 6 readings per hour. The hydrophones allow large distances to be covered, particularly on PVC. Used a smart meter system with LPR in 2006 with every non-domestic consumer metered and minimum night flow to automatically write to consumers with leaks. For major leaks on major mains, we in some cases used automatic close down to prevent flooding of properties. Were each of the black or leak points equipped with pressure gauges? So in short, were there pressure gauges on any of your smart meters? Did you have any other technology on the meters, such as correlation, on there? What are your thoughts,
Yeah.
Daniel?
So yeah, I mean, I can't obviously comment specifically on that product. It sounds great though, if it can do all of those things. We have we did when I was there. We did play around with similar. It sounds like similar devices that offer that kind of customer level insight into data and usage and everything like that. In terms of this project, we stuck to the network. As I said earlier, we did toy with the idea of having this idea of customer as a sensor, but didn't get as far as actually installing any devices to do that. Acoustics, we did do some work on acoustics. So we worked with some of the well-known acoustic logger providers, and we did. The idea was to try and use a secondary sort of validation. So where the pressure model identified, you want to go into this area of a DMA, could you then switch on and wake up some acoustic sensors to get you that last bit to really pinpoint the leak? Had a bit of success with that. The biggest problem we had was that it was actually getting the everything to sync up time-wise. Because acoustic sensors tend to only wake up once a day and do their thing, rather than constantly listening, which the pressure sensors are obviously doing. So I'd say there's more work in that area to tie those two technologies together. But I'd be really interested in doing that. I think it's got a lot of mileage.
Okay, fantastic. We've had some fantastic questions today, brilliant questions, in fact. Alan, you get the last question on here. Have you measured the percentage of false alarms triggered by ad hoc changes in consumption and not by actual bursts or equipment failure events? Can you differentiate those from the control room before deploying teams to the field? So, question really about false positives.
Yeah. Yes, Alan, we get them. I can't remember off the top of my head, I'm afraid, what percentage it was. It's not insignificant. And that's why, as I mentioned, we had to put a whole suite of processes in that meant that there was this triage layer, that the controllers, before they deploy, so they have to be sure that it is actually an event worth going after. Some examples of things that we do there: we have a second system that they can check the flows and pressures on, just to make sure there isn't something going on with the way the data is getting in. We have something called the known issues list, which is effectively a list per DMA of any sort of known problems or things that have happened in the past that might actually be causing that event, as opposed to a real network event. But yeah, in short, occasionally it's looking for change. It's non-discriminant on that change, so occasionally you will get false alarms, and that's something you have to deal with, I think, with any smart network, any situational awareness tool.
Okay, Luke, you have sneaked one in there just at the end. We'll let Daniel answer this one. So hi, Daniel, did you carry out any district meter, flow meter verification activity prior to deployment or integration of the system? And that's our final question.
Yeah, not as part of this project, but I have done in the past. In this project, as I say, it was about change. So we're not using this as a reporting tool, and therefore the absolute value of flow doesn't need to be spot on. Obviously, as part of leakage reporting, there are guidelines around doing that sort of testing. Yeah, and so I would definitely advocate doing that kind of testing as well.
Okay, brilliant. And then there's a recommendation for you to go check out something, Daniel. So, but just, we've got to our time now. We've had our hour. Thank you very much. The innovative work that you've done, really leading work, especially in the UK, with the smart DMA, with the 1 minute data, with being able to localize leaks and find them quickly and everything. I think it's great that you've been able to share that with us on the webinar today. Daniel, we had your email and we had Liam's email as well, that people can go if they've got any further questions. This will be going up very soon on the water loss, iWA water loss YouTube channel if people want to watch it or watch part of it again. But so thank you everybody for participating. Thank you, Daniel, especially, and for SES allowing you to share this case study. Okay, have a good day, everyone. Bye-bye.
Thank you, Michael. Thank you, everyone.
Daniel, can you just stop the recording? I might need to send you a request.
Yep, no, I can do that, I think. Let me give it a go.
Okay.
Are you sure you want to stop recording?